rewrite the standard form of the equation in slope-intercept form. 4x minus 2y equals 1. Well, the first thing we have to think about is we're being given an equation, as said, in standard form. So this equation in standard form is given to us as 4x minus 2y equals 1. Standard form means we're given an equation that looks like ax minus, plus by, this is the general form, equals c. A, b, and c are constants, and actually a, b, and c are integers, more than just constants. We're not allowed to have fractions for a, b, and c. And a has to be positive. So this conforms, the given equation conforms to the standard form of a linear equation in two variables. Now what they want from us is to rewrite this equation in slope-intercept form. So this is what they want us to change it to, slope-intercept form. So slope-intercept form is also the form of an equation, linear equation in two variables, but it looks like this. Y is on one side of the equal sign, left side typically, equals mx plus b. M, of course, wherever we see that in algebra, this version of algebra with graphing, stands for the slope. And the b, in this particular case, stands for, it's going to actually be the y-intercept, in literally the y component of the y-intercept. This is an ordered pair, 0, comma, b, and whatever that number ends up being goes in this position as the y-coordinate of the y-intercept. So our purpose is to solve, if we take any standard form equation, any equation in two variables x and y, and solve for y, bringing the x term and the constant over to the right side, and making sure that we have a positive 1 coefficient for y in the end, we'll have rewritten this that equation, the given equation, into slope-intercept form. Okay, so let's go ahead and start with a clean copy. 4x minus 2y equals 1. Here's our given equation, and all we're going to do to rewrite the equation in slope-intercept form is to solve for y. That's the way that we actually write an equation in slope-intercept form. So basically our goal is to rewrite this equation so that it looks like this. Positive 1y equals mx plus b. To solve for y in this particular case, to get it into slope-intercept form, we need to rewrite it in this form, and then we'll have satisfied the instructions. So first thing I would do is, we notice about slope-intercept form that the x term is on the right side. Well, the way it's given to us, the x term is on the left side. 4x we need to eliminate from the left side so that it will, when we balance the equation, it'll reappear on the right side. 4x is currently connected to 2y with subtraction. That limits us to add or subtract. This original 4x is positive. We're going to subtract to eliminate the x term from the left side. Well, to keep the equation in balance, we're also going to subtract 4x from the right side. That keeps the equation in balance. Now, if we were to write this, let's go ahead and simplify the left side. Equals, we brought down all the terms that we didn't deal with yet on the left side. On the right side, if we did this in order, it would be 1 minus 4x. But we want to work with this in a second. Let's go ahead and completely simplify the left side. 0 minus 2y is negative 2y. This wasn't necessary. I just wanted to rewrite it for to be clean. Okay, so here's negative 2y equals 1 minus 4x. And notice, we don't have this in the right order yet. I'm going to bring this over here. Negative 2y equals 1 minus 4x. And we're going to use the commutative property of addition to rewrite this so that x is first, on the left side, and the constant is last. Notice that this 1 is positive. If we were to insert a plus sign, like minus a positive 4x is the same as plus a negative 4x, then around this plus sign, we're allowed to exchange 4x, negative 4x, and positive 1. So let me go back to blue. And what we're doing here is we're putting the constant on the right side, positive 1, and we're bringing the x term to the left side because it looks more like slope-intercept form, which is what we want. So we just use the commutative property of addition. Negative 4x, well, we don't need any parentheses around that. It's still negative 4x this way, plus positive 1, well, 1 is still positive 1 without the parentheses. So here's this guy, negative 2y equals, we've had that on the left side of the equation. So we still have negative 2y equals negative 4x plus 1. Now it's simplified, and the x term, look, the x term is on the left side, and the constant is on the right side. First and last terms, the way slope-intercept should be. The only thing we have to make sure of, though, is because a big part of our goal is that we have to have a positive 1 coefficient of y to be able to say that we've satisfied solving for y. So because the coefficient of y currently is a negative 2, we're not there yet. We're not having a positive 1. So this time, our intermediate goal here is to convert negative 2 into a positive 1 coefficient of y. This negative 2 is connected to y with multiply. We're allowed to use multiply or divide to make an operation happen. So we're going to choose divide, and whatever this coefficient is, negative 2, we're going to divide by it. Because any number divided by itself makes what? It makes a positive 1. Positive 1. And we can't, which is our goal, by the way. Positive 1 y. Here's this y. So to make this happen on the left side, we can't forget that we got to always balance the equation out due to the right side whatever we had to do to the left side. So here's the long version. Whatever we did to the left, we have to do to the right, and that's divide by negative 2. So here's what ends up happening. Whenever you divide a polynomial by a monomial, negative 4x plus 1 is a polynomial, and we could treat negative 2 as a monomial. What we do is we give each of those numerator terms their own fraction bar, and we give each one their own denominator of negative 2. It's as if these were two fractions that were being added together. They have common denominator of negative 2. I mean, we could go back up and these two would come together as this larger rational expression, fractions with a variable we call rational expression. So, but what this gets us is we're getting closer and closer to a number times x plus a constant, because dividing by negative 2 doesn't get us there. We have to continue and break these apart. So it looks like an x term plus a constant. So splitting these up into two fractions gets us a little closer. So here's the idea. Next, if we just stick to the right side, this fraction, rational expression's got a variable in it, could have come from, well, if we show the numerator in factored form, and if we take the negative 2 in the denominator and show it as itself times 1, this could have come from two fractions that look like this. How do we multiply fractions? Straight across. So I'm breaking these up. I'm breaking this thing up into a number times x gradually, and hopefully this is making sense. This, when I write it in factored form, could have come from two fractions that multiply straight across. in this fashion. Now that we have individual, an individual number, which is the fraction, times x over 1, we could say, well, negative 4 divided by negative 2 is positive 2, right? Negative divided by positive is positive, 4 divided by 2 is 2, and any number or variable, which represents a real number, over 1 is itself. So here we have the mx, part of mx plus b. Now let's go look at this fraction over here. I'm going to put it in parentheses, 1 divided by negative 2. Now, of course, the 1 is a positive. The positive divided by negative is negative. And then we have 1/2. 1 divided by 2. Now, the rule for additive inverse says if we change addition to subtraction, like right now we have plus and negative, we can change it to minus a positive. So plus a negative 1/2 is the same as minus a positive 1/2. And I think we have that all simplified. So here's what's been running down the left side of these equations is positive 1y equals 2x minus 1/2. So have we succeeded in rewriting our standard form equation in slope-intercept form? I think so. Let's compare all the parts here. Our goal was positive 1y equals mx plus b. And we simplified plus b. Here is where it really looked like plus b. B is negative 1/2 because of the plus matching the plus in this form. But in simplified form, we really want to take this form with minus 1/2, and we could rewrite it one last time without any excessive parts, extra parts, and it would look like this. Y equals 2x minus 1/2. All I did was say 1 times y is y. And now it'll should look just like, hopefully we'll have an answer choice that looks like this because we have confidence that this is correct. Y equals 2x minus 1/2. When we come up here, I look for y equals 2x. This is a possibility. Y equals 2x. This one's not right. I don't have an x in this at all. This one's y equals negative 2x. Well, that's not right. A negative 2x, so it can't be this one. This has y equals 2x so far. It looks pretty good. So I compare. The answer has to be A or B. What's our constant though? Minus 1/2. 2x minus 1/2. Up here we see plus 1/4. That's wrong. So the answer can't be A. Here is just right. Minus 1/2. Y equals 2x minus 1/2. So we settle in that the correct answer choice, the correct response is D. Hope that helps. Thank you.